Yeah, we'll discuss today this MCQ level 1 alkane related. Okay, level 1 MCQs will be there. So let's see the question. You can try it, all of you. So the questions will be coming, options will be coming. I'll give you some time in between. You can think it and write the option in the page, and then you can check whether it is correct or not. You can send in the chat box also. So level 1, it's basic quiz, particularly for those who are preparing for NEET exam or CBSE or JEE main. It will be useful. For JEE advanced level, of course, it will be basic question, but till JEE main level, definitely it will be useful. So what will the IUPAC name of the following compound? Remember that longest chain rule we have to follow. Longest chain rule we have to follow. So longest chain you have to select. Accordingly, you have to do. And not necessarily longest chain will be given in a question in straight line. We have to select the longest chain, right? And based on that, we have to give the name. So longest chain, try to use it, try to think it, and try to answer it. And remember, the substituent should get the minimum possible number. There is only one substituent in this case, so minimum possible number. Okay, I'll show you the answer key, and then I will explain to you also. Of course, it is 1-methyl hexane. Sorry, 3-methyl hexane. So here it is. This is the longest chain. Okay, this is the longest. Now numbering we can start from here. 1, 2, 3, 4, 5, 6. So it is 3-methyl hexane. It is 3-methyl hexane. So IUPAC name of this compound is 3-methyl hexane. Each question you can give yourself correct +4, negative -1. In that way, you can see how much marks you are getting it. The number of sigma bond formed in ethane by overlapping of sp3 orbital. Remember, they are given sp3 orbital, not sp3 and s. So you should be careful when this type of question is there. They're not asking all sigma bond. They're asking only sp3 orbital overlap. Right? Try to think it, then I'll discuss it. You can send in the chat box if you are interested. I'll discuss then. See, first of all, sp3 orbital overlapping, there should be p in that atom. So that's the only possible here between carbon. See, there is a overlapping. There is a sigma bond between carbon hydrogen also, but that is sp3 and s. So the answer here is only one. So there is only one sp3 orbital overlapping, which is forming sigma bond. So answer is 1. Remember, sigma bond, if someone is asking, we can count all sigma bond. This is sigma bond, but this is sp3 and s. Right? This is also sigma bond, this is also sigma bond, this is also sp3 and s. This is also sp3 and s. This is also sp3 and s. But they are not asking all sigma bond. They are interested only sp3 orbit, which is this between carbon. So the answer is 1. Okay. How many type of carbon atoms are present in 2, 2, 3 trimethyl pentane? How many type means 1 degree, 2 degree, 3 degree, quaternary. You have to find how many types of carbon is there. 2, 2, 3 trimethyl pentane. So first draw the structure. Okay. You can stop the video. Suppose you are seeing the video mode, and you can draw it, and then you can see that solution. So 2, 2, 3. Trimethyl pentane. Okay. So you can see this is 1 degree. This is 2 degree. Sorry, this is 3 degree. This will be 1, 2, 3. This will also 3 degree. This will also 3 degree. And this will be 1 degree. So 2 degree is missing. Quaternary is missing. So how many type it will be? It will be only 2 type, right? We can say that only 2 type will be there. Quaternary is, which one is quaternary? 1 second. 2, 2, 3. Trimethyl pentane. Okay, 2, 2. Sorry, 2, 2. This will also be this one. 2, not this one. In this one. 2, this will be 4 degree. Yeah, 2, 1, 2, 2, this is not here. Yeah, so answer will be 3. So it will be 3 type. Okay, it's 2, 2, 3. So at the second carbon, there are 2 methyl. So yes, it is primary, secondary, tertiary, quaternary carbon. So all 4 will be there. Okay. Again, I'll just explain to you. Okay. Here it will. Now this is 1 degree. 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 First, let's identify all the 1 degree. Then this will be 2 degree because 2 carbon. This will be 3 degree and this will be 4 degree. Okay. So all 4 will be there. Primary, right? 1 degree, 2 degree, 3 degree. So all 4 types are there in this one. Okay. So drawing a structure is important because as you can see that one, we have to be careful while seeing the compound. Structure is not given. We have to draw it. Accordingly, we have to do. The correct IUPAC name of the following alkane is. Remember, the complex substituent also has to be named as per the IUPAC system. And minimum sum rule is always valid. So complex substituent we have to name properly. And then only we have to. So try to do it. Then I'll discuss. Complex substituent, you have to see it here. Okay. Try to name the compound. Of course, the longest chain will be this one, right? This is the longest chain. Right? But one more rule is there. If you remember, if the chain size is same, then we should go for maximum substituent. Suppose we will take like this. Still it is having how many carbon? 1, 2, 3, 4, 5, 6, 7, 8. So 8, 8 in both cases. Now what the rule is saying? If the length of the chain is same in 2 scenario, like in this case, then we should go for creating more and more substituent. It means we should select the chain in which maximum substituent can be there. Maximum possible substituent. Now, maximum possible substituent in which case it will be? Of course, in this case only it will come when we'll take like this. Because in this case, this will be ethyl, this will be methyl, then we are having three substituents. If we'll take a straight chain, we'll get two substituent, one complex substituent will come, right? So the correct way of doing this will be using this chain, taking this as 1, this as 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8. So it should be, as you can see, 3 and 6. Diethyl is there. Second one, methyl is there. Total is octane, right? So the only thing is, which option we'll go for? We'll go for first option, 3, 6, diethyl, 2-methyl octane. Remember, whenever we have the same length of chain in two scenarios, same length of chain in two scenarios, in two cases, then we should go for maximum substituent. We should go for maximum substituent. So that way we can say it is 3, 6 diethyl 2-methyl octane. Because in this case, we'll get 3 substituents. If we'll take the straight chain as 8, then we'll get only 2 substituents, which will be wrong. So we have to follow each and every rule. Remember that, not just one rule. We have to see that no rule should be violated. So first rule, second rule, third rule, like that we have to see. Okay, in the Wurtz reaction, normal hexane is obtained by, we discussed already in Wurtz reaction, what happens to the carbon chain? It multiplied by 2. Or both the chain will be connected together. Right? Normal hexane, 6 carbon we need. What we should take? They are asking. Very easy question. 6 carbon we need, hexane. What we should take? How much carbon we should take? So the double will be 6. So of course, in this case, which one will go for? First option, N-propyl chloride. Right? Normal propyl chloride. Then only the carbon chain will be becoming double. So 3 plus 3, it will be becoming 6. When sodium acetate is heated with soda lime, the reaction is called sodium acetate. We discussed this sodium acetate. Then what this reaction will be? What will happen? What will happen here? What will happen to the carbon chain? Will it be any change here? So we discussed carbon chain will be reduced. Decarboxylation. Okay. One carbon will come as Na2CO3. So length of the carbon will decrease. So decarboxylation. Second option. The gases liberated at anode in electrolysis of sodium acetate are. Just try to answer it. At the anode, what will be liberated? Reactions we discussed fully. That alkane and CO2. So C2H6 and CO2 will be liberated. The following substance react with water to give ethane. Ethane. Now, this is important to one reagent. We discussed that the purpose of that reagent is the main purpose, or we can say easily it can form alkanes. We discussed it is Grignard reagent, right? All the Grignard reagent on very easily they can convert to alkane, right? Very easily they can convert to alkane. So which one will be the answer? C2H3 MgBr, C2, it should be C2H5 MgBr. Okay, just you can rectify it. C2H5 MgBr it should be. So C2H5 MgEBr will give us ethane. ROH with RMgX. Again, Grignard reagent RMgX. RMgX. What will form? What will form? Which alkane will be formed? Just now we discussed before this. RMgX. So what R will do? It will take H. Right? So answer will be RH. RH. Okay. Okay, 1 second. Here, this is H dash, it should be. So R dash H will be correct answer. Okay. R dash H will be correct answer. Okay, so just rectify it. In slide, some issue was there. So R dash H will be the answer. ROH. Remember, Grignard reagent, this R dash will take H very easily. Even with water, it is okay. We don't have to use the alcohol also. So rectify accordingly. This one R dash MgX it will be. So R dash H will be the compound. Sodium salt of following acid which is needed for preparation of methane. Remember, methane, sodium salt. And one more thing, it can be a decarboxylation reaction also. So accordingly, you have to think. We want one carbon. We want one carbon, but suppose there is a decarboxylation reaction, then it should have, we should have taken how many carbon? Based on that only we have to answer. So ethanoic acid, we have to take ethanoic acid, and based on that only we have to do. Okay. Any doubt, anyone? Decarboxylation reaction, CH3COONA plus NaOH CaO CH4 plus Na2CO3. Na2CO3, CO3 is somewhat missing, you can write it down. The solvent used in Urge reaction. Already we discussed the name of the compound, right? So many times in Urge reaction that it should be dry ether. So the last option, it is one of the ether, dry ether we are taking. Okay, now these questions will convert to properties. Arrange the following in decreasing out of their boiling point. Remember, for the boiling point, two things: branching and molecular weight. Molecular weight increases. Molecular weight increases. Boiling point increases. This is one rule. Second thing, branching increases. Boiling point decreases. Okay. So if it is having same number of carbon, see the branching. If number of carbons are different, not very like nearby, somewhat more distance, then we can directly say that molecular weight increases, boiling point increases. So one of the things is we have to see the length of carbon chain. Second thing we have to see branching. Based on that, we have to do for decreasing order. So we have to select first one which is having maximum carbon straight chain. Maximum carbon straight chain. Right, that is the first one. So based on that, try to do it. You will get the answer. First one should be maximum carbon straight chain. So in this case, the answer will be fourth option, which is normal pentane 5, then 2-methyl butane, still 5 is there, right? Carbon is 5. Then fourth one, 2,2 dimethyl propane, still 5 carbons are there, and then 1 normal butane. Okay, so molecular weight increases, boiling point increases. Molecular weight is what? Number of carbon. Number of carbon is more, molecular weight is more. Branching increases, boiling point decreases. The compound with the highest boiling point is highest boil. Again, same logic. Highest boiling point, maximum number of carbon or maximum molecular weight. Straight chain, maximum molecular weight, straight chain. Of course, we can see here that first option, normal hexane, straight chain, maximum number, right? So same logic for all boiling point related. It's very simple logic. Molecular weight increases, that is number of carbon increases, boiling point increases. Branching increases, boiling point decreases. Because if branching increases, van der Waals force decreases. The increasing order of reduction of alkyl halide with zinc and dilute HCl. Zinc and dilute HCl. Reduction of alkyl halide. Alkyl halide with zinc and dilute HCl. This is one of the properties we discussed, right? RCl, then RBr, then Ri. Nitroethane can be obtained from ethane by following. Nitroethane means nitration. They are asking basically how the nitration we can do, right? Nitration, how we can do the nitration. So in this case, nitration of alkane, one normal thing we discussed already. Action with HNO3, 400 to 450 degrees Celsius. Conc HNO3. Okay. So nitration of alkane, option C will be correct. A mix of CS2 and H2S on passing over heated copper, what it will give us? What it will, remember CS2 and H2S. CS2, carbon is there. Heated copper, what will happen? One carbon, methane will be formed. So the product formed is methane. The volume of oxygen compared 4 liters of ethane. 4 liters of ethane. What the formula? Try to recall the formula. Cn H2n plus 2 plus 3n plus 1 by 2 O2. Right? So 3n plus 1 by 2 O2. So how much it will be? For 1, we need 3n plus 1 by 2. For 4, how much we need? 3n plus 1 by 2 into 4. How much it will be? 2 times 3n plus 1, which will be 2 times 3 into n is how much? What they are asking? Ethane 2. So 6 plus 1, 7 into 2. So how many liters we need? We need 14 liters. Okay, for 1 liter we need 3n plus 2, 3n plus 1 by 2 liters. For 4 liters, how much we need? 3n plus 1 by 2 into 4 liters. 4 by 2, 2. 2 into 3n plus 1. N is 2 because it is ethane. So 6 plus 1, 7. So 14 liters. So 14 liter we need. Remember the reaction, it will help you for so many questions like this. So what is the requirement of oxygen? 3N plus 1 by 2 O2. N-butane converts into isobutane by normal butane converts into isobutane by. So chain has to be changed. We discussed already that chain polymerization, right? Oh, sorry, isomerization. ZnHCl. Isomers will be produced. 2-methyl propane on oxidation with KMnO4. Oxidizing agent. 2-methyl propane. So instead of H, what will come? Instead of H, hydrogen will be replaced, right, by OH. So 2-ol, 2-methyl prop 2-ol. Mild oxidation gives alcohol. Okay, so this conformations we'll discuss next class.